so your question is this one. So you're trying to differentiate this, okay? And because this one here, it actually, you can think about as 3 different function multiply, but you can also think about as this function multiply this function. So we use the product rule first. So thinking about this as the first function, that's the second function. So we differentiate the first function here with respect to theta, and then over times the second function, sin theta, and then adding the first function times the derivative of the second function. Okay. And then what we have over here is, and for this one over here, we use the product rule again for this one.
Okay.
Because it's a product of this function, this function. So I'm going to differentiate the first function. So this time we just go ahead and do it. Differentiate the first function here. The data here we get 1, right?
Yes.
So we got 1, and then times the second one is cosine theta plus now the first function theta, and differentiate is
negative sine.
Negative sine theta, right? Yeah, good, very good. So it's negative sine theta. Okay, now times sine theta as theta cosine theta. Now, when we differentiate sine theta here, we get cosine theta, right? So we get cosine theta. Okay, now we just need to see we can simplify this. So this one times that is sine theta cosine theta minus theta sine theta squared plus theta cosine square theta, right?
Yes.
Okay. And over here, if I take out this.
Oh, okay. So you can factor out the theta and then make sine squared theta plus cosine theta.
But this one happened to be minus. This happened to be minus.
Oh, right. Okay. Sorry.
Yeah, so then that will make a difference. If it's an addition, then okay. But that's a very good point. Yeah, I was thinking about that, but I realized that this is a minus.
Okay. Right. Okay.
Then you have, actually, there's also another identity you can use. So do you remember the double angle formula? Sine of 2 theta. That's equal to 2 sine theta cosine theta, right?
Yes.
Angle formula. And then cosine of 2 theta, that double angle formula is actually cosine square minus sine square. And this one you might not remember, but it is one of them. So this is the one that you probably, yeah. So these two are the double angle formulas. So I'm thinking this one over here now, okay, let's think about this. It's this part right here, same as this one. So sine theta times cosine theta is half sine 2 theta. So that one I can actually put it as half sine 2 theta. Right? Okay. And then for this part right here, I can actually take out data, as you said. So we can take out data. So minus data, and then I will have sine. Actually, I want to have a plus theta. So that way, the reason for that is that way I will have a cosine square theta minus sine square theta. Just that way.
Okay.
So that will remind me of this double angle formula over here.
Yeah. Okay.
So that will become cosine of 2 theta. I think that's the as far as you can get.
Okay.
Even if this is an in-class test, if you need the answer like this, it should be still correct. But this answer and this answer here, they are equivalent. Both of them are
Okay. Okay.
Let
So
me
we don't
check.
have.
So do you know our textbook, they have answer for odd number? So let's go down to the back of the textbook and let's see. 3.3. We have 3.3 number. Yeah, it has all the odd number problem.
Oh yeah, you're right.
3.3. You see it?
I see it.
3.3. I'm still checking. Okay, 3.3 number 15. Number 15. Yeah, we got it right.
Yeah.
Yeah.
Except the theta there. Yeah. Okay.
Oh, yeah, I
got it.
forgot data.
Yeah.
Oh, I forgot the data here. Yes, yeah, we got it. You got it. Good job. But if you need the answer like this, nothing is wrong. Nothing is
Okay.
wrong. And it's equivalent to this. Yeah, so that's now you see that you can actually check the answer at the back. So you know
Okay.
sometimes
Okay.
sometimes you can
that's
check
right.
it that way. For number 45. Number 45. Okay, let's do it together. You know, this is the first
Okay.
time I do it too. So I'm doing number, I might not get it right, but we can work together. Okay, so that is going to remind us to use this important limit, right? Sin data over data,
Over
that's equal
theta.
to 1. So we want to use this one over here. So I'm trying to make this change them so that I get closer to this. So I notice that whenever I see tangent data, I probably want to change that to sin data over cosine data that way.
Okay.
So that will be, let's try that. If it doesn't work, we can try something else, you know. So data plus sin data over cosine data. Okay. Now after that, then we take a look here and say, oh, this is like a complex expression, right? So how about we multiply up and down by this LCD, which is cosine data.
Okay.
I'm just trying. It looks more complicated here now, but let's try that. Okay. You know, I have another idea also. I'm looking at if I make this the reciprocal, I can actually easy to find the. Okay, let's try the another way later on. Okay, let's go ahead and see if this one works. Okay, so then let's say limit data go into itself, sin data, cosine data. Ooh, that looks more complicated, isn't
Yeah,
it?
it does.
They look more complicated. So I'm wondering that might not be the right way. So I'm thinking that make it complicated is because I have actually two terms in the denominator. So how about instead of finding this limit of this one, how about I find the limit of the reciprocal of this? That might be, because that way I have only one term in the denominator. Okay, if I can find the reciprocal, the limit of the reciprocal of this, then I can take the reciprocal, then will be the limit for this. Yeah. So I'm trying to find the reciprocal, the limit of the reciprocal. So I'm going to turn this upside down.
Okay.
Flip this. That way, after I find that limit, I can just flip it again to get the limit for this. Okay. Because the reason I want to flip it is because there's only one term right here. Okay. So now I'm going to try this one. So to do this, again, I'm going to. So I can break it this way: data over sin data, right? And then this one here, tangent data over sin data. Tangent is sine over cosine. And now divide by sin data. So that will be just 1 over cosine data.
Okay.
Yeah.
Okay, which is
divided, right?
Okay.
Divide out, right? So it's 1 over cosine data. So plus 1 over cosine data. Okay. Now remember the important limit, right? So
yes. So we 1 plus.
Yeah. So this one, even when theta over, remember this is also
Yes.
equal to 1.
Yes.
That's also equal to 1. That's also equal to 1. Okay. So this
Okay.
will go to 1. Okay. So that will be equal to, that will go to 1. And what about the other one? 1 over cosine theta.
So that'll go to 1 as well?
Yeah, you got it.
Okay.
If you substitute theta to be 0, then that will be 1. So that will be 1 and that will be 1. So that will be 1 plus 1. So that will be 2.
Okay.
That's equal to 2. But this is not the answer we have. The one we take limit is the limit of this reciprocal, right?
Uh-huh.
If the reciprocal go to 2, what about this itself?
So you just take the reciprocal of it, right?
Yes.
Okay.
So you got it. Good job.
Yeah.
Okay.
Okay.
So therefore, let me write it down. So sine theta
Oh, okay.
over theta plus tangent theta. So that will be 1 over 2. So that's the answer there.
Okay.
Yeah. So sometimes
Okay.
you could be a little bit creative.
Right. Like it didn't even occur to me to take the reciprocal of it to begin
Yeah,
with.
because when I first look at it, I said, this one have 2 chain in the denominator. It's going to make it harder. If it's the other way around, if I only have sine theta and in the denominator, and that will make it easier because that way I will have this because it will remind me this one and this one because of that. So we try different things. It's like kind of like a try and error first.
Yeah.
So that would be 1/2. Yeah.
Okay.
But that's a good question. I was thinking about this problem again this morning, and I think there's another way to approach this problem over here. So because we want to use this limit, so this problem here we might as we want to use this important limit over here. I have theta and have sine theta, so I would like to divide this expression here up and down by sine theta. That way I will have a theta over sine theta here, and then this one also will be changed. So how about we try to get this closer to this? So by dividing sine theta up and down. Now once you divide sine theta up and down, you get 1 in the numerator, theta divided by sine theta. Now tangent theta divided by sine theta, the sine theta here will divide out, giving you 1 over cosine theta. And that way, when theta approaching to 0, theta over sine theta, which is this one over here, this limit is equal to 1. And this one here, when you substitute 0 into theta, cosine theta is 1, so 1 over 1 is 1. So the limit of this as theta approaching to 0 is 1, and the limit of this as theta approaching to 0 is 1. So this limit here is 1 over 1 plus 1, which is 1/2. So we got 1/2. Same result as what we have. So this is a way that we can do this problem here directly. It's just another way to do it.